Hey everyone, today we are solving LeetCode problem number 872. Leave similar trees. In the problem, it is saying that consider all the leaves of a binary tree from left to right. The values of those leaves form a leaf value sequence. Okay, it is saying that if we consider all the leaf node from a binary tree from left to right, like this 6, 7, 4, 9, 8. What is this forming? It is forming a leaf value sequence. So this is the leaf value sequence of the above tree, and two binary trees are considered leaf similar if their leaf value sequence is same. And here we have to return true if and only if two given trees with head nodes root 1 and root 2 are leaf similar. Okay, so we are given two binary tree. We are given root of those binary tree, and we have to see whether those two binary trees are leaf similar or not. And what is the condition for that? The leaf value sequence should be same for both of the trees. Okay, let's try to understand with an example. Here, these are the two binary trees, root 1 and root 2. Okay, now what we have to figure out is whether these two binary trees are leaf similar or not. So for leaf similar, the leaf value sequence should be same. So what is the leaf value sequence for first tree? 6, 7, 4, 9, 8. 6, 7, 4, 9, 8 is the leaf value sequence for first tree, and for the second tree we will check the leaf node from left to right. This is the leaf node 6, 7, 4 is the leaf node 9, 8. 6, 7, 4, 9, 8. Okay, these two values are same. So if the leaf value sequence is same, it means both of the trees are leaf similar, and we will return true. If I have a look on this example, here in this example, what are the leaf nodes? 2 and 3 are the leaf nodes. And what is the leaf value sequence? 23. And what is the leaf value sequence for this tree? 32. Or maybe you can say 32. So these two are not similar. It means these two trees, binary trees, are not leaf similar. So we will return false in this case. So from this example, we can see what we have to capture is we are first of all we are given root 1 and root 2. From root 1 and root 2 we have to figure out the leaf value sequence of both the trees. So leaf value sequence of the first tree is this, for the second tree is this. We can you can capture it anywhere. Let's say I'm capturing it in a list. So from the first root value we have to capture the leaf value sequence list. For the second root we have to capture the leaf value sequence root list of second tree, and after that we can compare these two lists, whether these two lists are similar or not. How we can check? We can just check one by one each element for these trees, these list. Okay, similar for this. From root 1 to root 2 we will form the leaf value sequence of both the trees, and then we will compare these two values. And how do we capture the leaf value sequence? We have to note that we have to capture it from left to right. It means our left node should come first before the later right node. So for that we'll have to process the left tree first and then right tree. To capture the values of leaf node from left to right, what we can do is we can do the in-order traversal, where we generally process the left subtree and then root and then left subtree. When the left subtree is done, we will process the root. We can check whether the values is leaf node or not. If it is a leaf node, it means that left child and the right child both are null, and we can add that to our list. And we will keep on adding all the leaf nodes from left to right. So after one complete DFS call over this tree, we will have the complete list of leaf value sequence. So we are going to do the same thing with the second tree. For that, we will get a leaf value sequence 2 from the second tree, and we will compare whether these two lists are same or not. Okay, to do the DFS, we are going to take a time of O of n. N is the number of nodes. N should be equal to t1 plus t2 time taken to traverse the first tree, then the second tree. Let's say first tree is having n nodes and the second tree is having m nodes, n plus m. So ultimately it is a linear time as well as it is a linear space. So you can say on time and on space. N is sum of all the leaf nodes from first tree and second tree, and here it is for the recursion stack. So this is the time and space complexity. Okay, now let's quickly code this problem. First of all, we have to take two lists. These two lists will store the leaf value sequence of both the trees from root 1 to root 2. So to store the leaf value sequence, I am writing a solution function where I will pass the root and the corresponding list. And now make another call to root with root 2 and store leaf value sequence in second list. After that, we'll just have to compare. First of all, we can check whether the size is equal or not. First dot size not equal to second dot size. Here we are directly clear that these two sides are not same. It means the sequence is not same. We can return false. Otherwise, iterate first dot size I plus plus if first dot get I not equal to second dot get I, return false. Anyways, return true. Now we have to implement our solution function private void solution tree node root, and the second value is list of integer list. Here you can do the in order directly. Solution with root dot left, process the left part and add the leaves in list. Now process the right part, root dot right, and add in the list. Add terminating case if root equal to null. Return, just return. Now if we are at a root node, it means left subtree and right subtree are null. Root dot left equal to null and root dot right equal to null. It means we have to add this value in the list. List dot add root dot value. Now my list is prepared and list has been compared. Let's test our sample test cases. On the sample test case, it is passed. Submitting the problem. Submitted successfully. Hope you understood the problem. Thank you guys.